Thank you, Tim. Thank you, panelists. We're going to shift gears now a little bit. We're going to start to talk about nuclear energy, which is really gaining traction across the U.S. and particularly in Wyoming. So today, for our last keynote, we have a president of a company that's building a new type of advanced nuclear reactor, the small modular nuclear reactor. So please join me in welcoming Joe Miller, president of the BWXT Advanced Technologies company, which is focused on demonstrating and deploying this new nuclear technology for terrestrial and space applications. Joe?
All right, thank you, John. Thank you, everybody, for all of the commentary and discussions we've had so far today. Throughout the day, I've heard a lot of interesting speeches. Dr. Krupka talked a lot about Wyoming being the energy state, and I hear that quite a bit. And BWXT has been working within the energy state for the past couple of years to discuss what does microreactor deployment look like. What are the assets that currently exist? How can those assets be deployed? What does industry want? What does the state want? How do supply chains get involved? And how do we integrate a new energy future in Wyoming? And we also heard from Dr. Campbell. She talked a lot about where the resources are in Wyoming. I fixated on uranium for very obvious reasons. But just to know that there's a lot of focus happening from the resource extraction industry, how geological deposits are understood and documented and communicated throughout the state is just another interpretation by me that there's a tremendous amount of focus on what the future holds. And the future was how Governor Gordon ended his speech, and he talked a lot about what's happened historically and why looking to the future is so important. And that's really what captivated our company. And we have several projects that are happening within BWXT, but what captivated us and for us to focus on Wyoming was the response that Governor Gordon has given us, what Rob Krieger from the Energy Authority has given us, and several others, and affording us an opportunity to take stake in Wyoming, understand exactly what a deployment scenario would look like for new nuclear, and then be able to integrate everything that we're doing as a company, as BWXT in the nuclear sector, and bring that opportunity to Wyoming. So with that, I'll go. Oh, my presentation's gone. All right, there it is. Okay, good. So talk a little bit more about what BWXT is. And BWXT's been a company, we had the moniker Babcock and Wilcox for over 100 years. So Babcock and Wilcox started in the mid-19th century. And if energy was required, Babcock and Wilcox was there for a variety of different ways, for big boilers, for coal, for natural gas, for trash burners, for anything that existed in energy, Babcock and Wilcox was there. And when nuclear became a technology that this country was very interested in, Babcock and Wilcox was also there. And if you're familiar with how nuclear started in the U.S. and worldwide, it started with the nuclear navy. We had to show that there were peaceful uses for nuclear technology. The first of those peaceful uses was in the strategic deterrent. Strategic deterrent for us means nuclear submarines. So a nuclear submarine program started in the 1940s. Our company started a nuclear reactor manufacturing facility in the late 1940s, early 1950s in Lynchburg, Virginia. We've been operating there ever since, and we've been manufacturing reactors there ever since. And in total, we've delivered over 419 nuclear reactors. And one of those nuclear reactors was on the USS Norfolk, where my first job out of high school was on the USS Norfolk, which is a fast attack submarine. So I started to understand a lot about nuclear at an early age and understand the power density that exists in uranium, the power density that can be harnessed for propulsion, for power, for peacekeeping, and eventually for the commercial pressurized water reactor fleet. And so there are over 95 PWRs here in the United States, and United States is a leader in nuclear technology, but other states and other states that are adversaries, other countries that are adversaries are starting to pick up quick. So the government, the U.S. government and the commercial industry and states like Wyoming are taking a renewed interest in nuclear and how that can be used to help with the economic vitality and ultimately with our vitality as a country and as humankind here on Earth. So I'll talk a little bit about those projects, but a little bit more about our company. We have 14 manufacturing facilities with over 4 million square feet of manufacturing that exists in Ohio, in Mount Vernon, Indiana, in Tennessee, in Virginia, in Cambridge, Ontario. We've been in Canada since the late 1800s. And so manufacturing is what we care about. We care about building high consequence machines, whether they be steam generators or nuclear reactors, but building those machines the right way, having those deployed, have them operational, and have them function in highly reliable states is really important to us. So we manufacture a variety of components, not just nuclear reactors, but also steam generators and feeder tubes and a variety of other things that are really important to the operation of nuclear reactor steam systems. So I manage a portion of BWXT called Advanced Technologies. So we focus on everything that's new and different inside of nuclear for the company. And we have 3 major programs. We have about a dozen programs in total, but 3 major programs. And on the outside of the slide, you see Project Draco. That's a space reactor program. So we are building that reactor now. It's a about 200 megawatt thermal reactor. That's the size of a 55-gallon drum. That reactor will be integrated by Lockheed Martin at the Cape in 2027. So Kennedy Space Center will launch that reactor into space. We will prove that you can use a nuclear reactor to provide the thermal energy to heat up rapidly cryogenic hydrogen to an almost plasma state to create a tremendous amount of volume expanse. That volume expanse through a nozzle creates thrust in space. So that's one project we have. We also have Project Pele. Project Pele is a Department of Defense program that is focused on putting a nuclear reactor in a 20-foot ISO container to look like every other ISO container that exists on Earth. There's millions of these things that exist on Earth. So being able to put a reactor inside of one, using 3 other ISO containers to hold the balance of plant, the energy conversion systems, the heat exchangers, things of that nature, is very important because the U.S. government needs energy all over the world for a variety of things to maintain our peacekeeping mission. So Project Pele is about 4 years into the making. We are building that reactor in Lynchburg, Virginia as well. So I have 2 prototype reactors that are being built, one for space travel and the demonstration of space travel and the use of nuclear reactors in space for propulsion. And then also Project Pele, which allows the U.S. government to have over 1 megawatt of energy on demand without refueling for 3 years at a minimum anywhere in the world and on very fast camping and decamping in theater scenarios. In the middle is what I'm here to talk about, though, and that's the Banner reactor. So the Banner reactor, the BWXT Advanced Nuclear Reactor, is a variant of Project Pele. So as we went through the Project Pele design sequence, we went through a competition. There were 2 other companies that we were competing with from 2020 to 2022. When we ultimately won that competition, we decided to, we were awarded a contract to build a reactor. And we had already had a project through the Department of Energy to ramp on a few different additional technologies to increase the performance of the reactor, use what we have done in Pele with those new technologies, and go look at commercial applications for the reactor. And it's interesting because we weren't really sure what the timelines for commercial were going to be back in 2020. In fact, our prediction as a company was the commercial market would start getting interested in microreactors in 2028. Well, 2 years ago, we started talking to the Trona Patch here in Wyoming. 2 years ago, we started talking to the Trona Patch because energy security is becoming a much bigger deal than it was 5 years ago. Also, the supply of energy, what we're doing with regulation and other factors are causing industry users to think more about what nuclear products can bring to the marketplace. So we all know that there's another nuclear project here in Wyoming. It's focused on putting nuclear energy on the grid. On-the-grid power supplies are really important. Microreactors are used for different use cases. Very industrial. They're industrial machines that can be used to provide thermal energy and electrical energy. And most of the energy that's used in the Trona Patch, or the concept that we have right now with Tata Chemical and others in the Trona Patch, is to use most of the thermal energy for process heat. The beauty of high-temperature gas reactors that are microreactors, they produce an extreme amount of temperature. The fuel is encapsulated at the very low volumes, which means you don't need to have large stick builds. In fact, you can move these reactors in, connect them, and operate them within a series of days. And then you can start to connect those reactors in sequence, or in parallel, and allow the end users, the industrial users, to continue to buy more reactors as they need more energy, more thermal and electrical energy. So it's not a one-for-one replacement on anything that currently exists. It's a new way to look at energy infrastructure. And that's what microreactors do. Small modular reactors are usually about 10 times the size of microreactors, and they're focused on grid applications, usually on some remote, rural, and sparsely populated areas. And big gigawatt plants, like you've heard from Westinghouse as an AP1000 plant, those are used for big metropolitan areas and supplying the energy that's required in those areas. All right. So across the timeline of how we got to where we are today through the Banner project, it started off with an oil and gas company coming to BWXT. They essentially said, hey, we saw that you're part of Project Pele. We know that you have a microreactor design. Could you use one of those microreactors in northern Alberta to help us with resource extraction? And we weren't really sure. We hadn't been focusing on that use case. So we did. For about a year, we spent focusing on that use case. We understood more about what a remote microreactor would look like in a harsh environment. And then we started to elaborate more and more on what the technical design features needed to be for an industrial machine versus a tactical defense machine. And when we learned all of that, the Department of Energy put out a bid, an RFP, for companies to come with ideas on how to commercialize new nuclear. So luckily for us, all the work that we had done for that company, we put into a proposal, and we won that proposal for about $111 million so we could upgrade essentially nuclear technology to meet the industrial end users' use cases. So that was in 2020. In 2023, like I mentioned, we started having conversations with Wyoming. It was early in 2023, and the Energy Authority was looking at a variety of different energy investments for the state of Wyoming. There's one of the 10 investments focused on nuclear, and we were able to use an investment by BWXT to cost share an award through the Energy Authority. It's total $20 million worth of scope to spend even more time here in Wyoming focusing on the supply chain, focusing on how to manufacture reactors in the state, and then also fully understand how you would deploy a microreactor in the Trona patch. And so that's our primary focus, is the Trona patch. And so all of the producers in the Trona patch we've talked to, we understand what their site requirements are. We understand what their current energy infrastructure is, when those timelines will expire, when they have to make big capital investments, how those capital investments can use on-ramp of nuclear microreactor technology, all the nuts and bolts of business, the conversations, all the nuts and bolts and system engineering requirements for each one of the inputs that those end users need. And we're putting that into a business case, because we're not going to build reactors and look for somebody to buy them. That's not a good scenario for nuclear. What you really need to do is understand what the end users need, customize the reactor system for that end user, and come up with a product that is universal. So when I say customize, I mean come up with the right design for industrial users and then mass produce nuclear. It's something no one has ever done in the world, ever. Nobody's ever mass produced nuclear. We build more nuclear reactors than anybody in the United States by an order of magnitude, and we still only build 2 or 3 reactors a year. Microreactors give us an opportunity to mass produce, meaning 10 or 100 or 200 nuclear reactors every year. I think that's really important to understand, because it does change the paradigm in which nuclear companies think about the future. It also changes the paradigm in which you can look at different deployment scenarios and cost reductions, and how we can treat nuclear with a lot of technology that currently exists through different control systems, remote monitoring, AI, all those different aspects of technology that are being used in high consequence systems like plane flight and aerospace and ICBM technology. I mean, all that technology uses autonomous control systems. The physics basis of a nuclear reactor is very amenable, quite simple as compared to those other use cases. So being able to apply new technology to nuclear, get into a paradigm of mass production, I think is really important. And that's what we're geared towards. And that's what energy security needs. And that's what we need to be doing in the microreactor segment of new nuclear technology. All right, so more about what we are doing in Wyoming. Like I mentioned, through the Department of Energy award, we were focusing on upgrading the performance. So performance of nuclear fuel is either longevity or power output. You can choose between those two things on how you operate the reactor. So optimizing the way in which our fuel is manufactured or designed and manufactured is an important part of that. And then looking at different sensors so we can go into semi-autonomous mode. Instead of having 25 nuclear operators for every reactor, which is pretty common for submarines or aircraft carriers or even commercial power plants, getting down to a semi-autonomous mode so you can monitor these and operate these reactors remotely. And then supply chain development is also crucial. We haven't ramped up in nuclear production in the United States in several decades. So understanding what the supply chain is and how it currently exists and how you can modify supply chain attributes, especially here in Wyoming, to meet nuclear capacity and meet nuclear build timelines. The great thing that we learned about Wyoming pretty quickly was the mining industry requires a lot of very intricate and precision manufacturing shops here in the state. And so we've been using a lot of the insight from those shops on how we could use their machines, their people, their production, and ultimately their business model to help us mass produce different nuclear components. We've established a variety of great relationships here in Wyoming regarding the supply chain, but then also just the material supply, how energy logistics are thought through in this state and how that can be directly applied to what we want to do in microreactors. So the first phase of our Energy Authority project started in 2023. That is complete. So we started looking at what the generic design would look like to meet the needs in the Trona patch. We offered us a document that summarized all of our supply chain interactions. And then we talked about licensing here in the state. So we had the benefit of being in the wake of TerraPower and what they learned, both positive and negative, from the influence of the U.S. government. And so as the state regulatory bodies came and participated in this study with us, we started to learn more about what a roadmap would look like for microreactors and deployment scenarios and ultimately production here in the state. From there, phase 2 was awarded earlier this year, and phase 2 takes it to another level. And that other level is now let's put some details and let's figure out the exact roadmap so everybody here in the state fully understands what our approach would be. And then starting to talk in deeper business conversations with the Trona producers, what part of the microreactor deployment scenario do they want to participate in? BWXT is a reactor manufacturer. We're going to need operating companies, and we have great relationships with several of them. We also are going to need capital, right? So these big projects are going to need capital infusion. So most of the Trona producers are very interested in how they can participate. Obviously, they want the energy. That's really important to them, but they also need to know, as first movers here in the United States, what is that overall benefit? Because we all know as you get into production, costs ultimately come down as you increase the magnitude of production. So what is the first mover advantage? So we've been focusing on that a lot too, because the business case has to be there along with the technical case. And so as we go through our analysis and produce additional summaries and continue to interface with folks inside of Wyoming, what's becoming very clear to us is this is a new paradigm, not just for BWXT on how to deploy nuclear, but it is a new paradigm on how you address energy security and how you think about what energy prices are in 10 years, because they've gone up substantially over the last 3 years. So pricing something that was a year ago or 2 years ago or even currently isn't really all that helpful. Let's think about what is 10 years and how can you ultimately integrate the costs that always are required for something first of a kind and eventually nth of a kind. How can you integrate those costs in your overall business model? So once again, it's an important part of not just selling technology, not just selling industrial machines, but also collaborating with those end users so we all see the benefit before we make big capital investments. And then phase 3 is really notional. How do we go off and do what we learned in phase 1 and phase 2? And when we do that, what are the site requirements and how do we get into scenarios where that supply chain and all of the construction activities that have to exist are pretty well orchestrated throughout the state so we can continue to build out what we learned in phase 1 and phase 2. And in addition to that, we have an MOU with the state of Wyoming that we signed very recently to look at producing this nuclear fuel in the state as well. So nuclear fuel is produced in a variety of different locations, but microreactors, especially our microreactors and several others that are out there right now in design, require a fuel called TRISO, and we manufacture that at an industrial scale in Lynchburg, Virginia, but it's inside of a protected area that's focused on, a variety of other defense applications that we have as a company. So it's not all that inexpensive to manufacture. So when we look at how do we ramp up production, we talked to Wyoming first and said, hey, if there was a production facility here in the state, what would you be interested in? What natural resources would have to exist? So we have another layer of investigation that's occurring here in Wyoming to focus on fuel production, in addition to deployment scenarios and manufacturing scenarios. All right, so we signed a public agreement with Tata. Tata Chemicals was very interested in being that first mover. They see the future in Trona in Wyoming, and they also see a risk with energy security here in Wyoming, energy costs in Wyoming, and not being able to control their own destiny because of where that energy and security and costs may go. So we've had a great set of conversations with them on the technical aspects of our microreactor, and then the business aspects of an operating company that would go off and produce these reactors, deliver, and ultimately operate each one of these reactors. And in addition to Tata, the interesting thing that we've learned is there's really no competition when it comes to energy across the Trona Patch. If one of the Trona Patch producers is interested in a technology, the best way to drive down cost is get all of the Trona Patch producers to focus on that same energy source. So we're seeing a good amount of collaboration in that area to help us figure out what the ultimate deployment scheme would be. So next step for us are to finish the conceptual designs of the reactor and to meet all those requirements that I went through from each one of the locations, to look at the fleet economic assessment. It's not just about first of a kind, it's about 20, 25, 30 reactors delivered in a period of time, and looking at what the economics would result in that deployment model. And then regulatory engagement plan, that's pretty cross-functional from Wyoming and from the federal government. So being able to do that in a very pragmatic way is ultimately important for project success. And then demonstrating the supply chain, starting to build out these reactors using the supply chain that exists here in Wyoming. Doing some early fixturing, manufacturing development is also key for us, so we can put reasonable timelines on each one of our delivery scenarios. And we expect all of this work to be done in August of 2025. And so for us, when we look into the future, like Governor Gordon said, nuclear can be a big part of that. But it has to be right for Wyoming, it has to be right for the supply chain, it has to be right for each one of those end users. And we're integrating each one of those aspects into what BWXT is doing here in Wyoming. All right, with that, I'll open it up to questions. Feel free to ask questions about the space reactor too, if you want. It doesn't have to just be about Wyoming.
So Christine will move around with the microphone with questions from the audience. But while you're generating, Christine will bring you the microphone, or I'll bring you the microphone. But while I'll get you, while we're doing that, question is public acceptance. When I was a student, nuclear was a dirty word, and now I'm looking around on campus across Wyoming, and it's accept. Can you comment on that shift in public perception and public acceptance to nuclear energy?
Yeah, I think it's a wide variety of things that has started to create a cultural shift. One, we've gone through a pretty extensive decade, maybe even 2 decades of integrating solar panels and wind and other energy resources, renewable resources throughout the world. And that's gone pretty well, but it's not enough. And so people understand that. So what do we do now? And so that's one aspect. The Russian invasion of Ukraine and causing a pretty massive disturbance on energy security worldwide is another influencing factor. And then I would just say the resourcefulness. Nuclear doesn't get a fair shake in a lot of conversations because of the emotion that goes along with different nuclear events that have occurred throughout the world. But the safety record is real, and it's extremely safe as compared to well beyond any other safety record of an energy production paradigm. So I think the resourcefulness of people, because of the internet, because of information, real information is available, has also helped with that case. And people take the environment seriously. We've heard that from every single presenter here. People take the environment really seriously, and having gigawatt scale production of energy with zero carbon is extremely appealing, and a technology that we all understand. This high temperature gas reactor is very similar to one that operated at Fort St. Vrain, just south of here, right? These reactors have operated throughout the world for several decades. This is not a new technology. We're using new technological advances in optimizing the way these reactors operate, but this is a proven technology that has produced just a tremendous amount of energy over the course of the last 50 years with zero carbon, and that is very important, I think, to every human in nowadays. So taking a fresh look at nuclear is creating that new acceptance, I believe.
Do you see any limits on how small microreactors could get? And you mentioned the one in space is about the size of a barrel of an oil barrel. Let's use oil.
Yeah, that's right.
Is it something that, when we look at the first computers, how big they were, and then everybody's got something way more powerful in their pocket right now? Are there any limits to scalability so that these things could be like the size of a refrigerator delivered out to somebody's house?
Yeah, so we have radioisotope power systems that have been operating in space that are like the size of Smarties, the candy. And so that provides just a few watts. So you would need lots of Smarties to help with the industrial applications in the Chona patch. So that's the smallest. And then you have gigawatts scale plants that are enormous. And it really depends on what the use case is. So that reactor that we're building for space travel, it only operates for a few hours. It only needs to, because space is at a vacuum. Movement in space is extremely efficient. It can produce 200 megawatts, but only for a few hours. So it really depends on the variations that you're looking for. But it's a good question, and you open up a lot of design space because uranium's so power dense. You have a lot of optionality there.
I just had a question about disposal and trying to find a way to, I guess, have acceptance for disposal, because obviously some landowner would have to accept it, and that's a big NIMBY issue.
Yes. Yeah, so disposal is a really important part of every nuclear technology. You have to think it's actually the only energy technology that you have to put in your licensing basis, how you'll build it, how you'll operate it, and how you'll dispose of it, and it has to be tracked the entire way, which makes me feel very confident that we're going to make good decisions all the way. But it also gets a lot of emotional response. And so the common graphic that you can see on Pandora's box and Netflix is you can fit all of the spent nuclear fuel in the United States that's ever been produced over 50 years in a Walmart. It's not that much waste, and it's easily contained, and you can store it for 10,000 years without issue in dry stored casks. But it is something that's really important for educating, and it is really it's something that's very important for tracking. And we start talking about mass production, that's a lot more fuel, that's a lot more disposal. So that's all part of what we're doing in each one of our studies with the DOE, the DOD, and through the Energy Authority. Yep.
You mentioned TRISO as your fuel. I've got a couple of parts to this question. One, is that a tritium-based fuel? And number two, you said you're manufacturing it on the East Coast. What are the costs and hazards with transport? And is it possible to produce it locally?
It is possible. So no, it's not a tritium-based fuel. It's a uranium-235-based fuel. So it's a 19.75% enriched U-235 by volume nuclear fuel. Excuse me. And yeah, we're making that and manufacturing that on the East Coast. There is a shipping container that's been qualified by the Nuclear Regulatory Commission to transport that fuel from the East Coast, really anywhere in the continental United States. And then there's international shippers as well. In fact, the fuel that we're manufacturing in Lynchburg will be transported to Idaho here in the next year for the Pele demonstration for the defense project.
It's 2:30. We're going to take a 15-minute coffee break, 15 minutes only. I encourage you to visit the student posters again and join me in thanking Joe for a very insightful, informative presentation.